Hi guys, Mr. Sutton here. We're given a graph of a function f, and we're given a definition of a function. I'm going to first look just at this first one over here. So let's focus on this first example. Given a graph of a function f, given a definition of a function g of x is the accumulation function, right? I'm integrating from 0 to x, f of t dt. That's the accumulation function. Well, what do we know is the derivative of the accumulation function? F of x, where f of x is, we're just replacing the t with the x right in here. So this is a graph of the derivative of g, okay? And since we know f is the derivative of g, we can answer some questions about g. Let's see what this first question is. I'm looking at this first example. It asks us appropriate calculus-based justification for the fact that g is increasing. Okay, now we don't have a graph of g here, but we do know g is increasing. Why? Well, g is increasing if the slope of the tangent line is positive, right? So, and f represents the slope of the tangent line. Well, it's positive all along our graph here. So because f is positive, we know g must be increasing. And we've done this exercise in a different form before. The only big thing you're focusing on is that we've given an accumulation function, g of x, and its derivative is, of course, f of x, and we're given a graph of that. So so we're asking us some questions about the original, or about the accumulation function g. Okay. Looking to the right here, what's an appropriate calculus-based justification for the fact that g is decreasing? Well, g is decreasing if the tangent slope is negative, right? Or if wherever f prime is negative. And we know that. Wherever g prime is negative, but g prime is f, right? Because this is the accumulation function. So g prime is f. So f is negative all along here. Therefore, this has to be decreasing. Okay? I think I can go ahead and do the next two. We've got another one here. The graph, we're given a graph of f again. So it's the same kind of deal. We're given g of x accumulation function. And so then g prime is f, so we're given g prime. G prime is the same as f, okay? Was an appropriate calculus-based justification for the fact that g is concave up? Well, concave up, remember, that's like the second derivative being positive, right? Wherever the second derivative is positive, we're concave up. But that means the second derivative positive means that the function is increasing as I go left to right. As the first derivative is increasing as I go left to right. And this first derivative is increasing as we go left to right. So it's because this first derivative, which is f, is increasing. That would indicate that our function g, the accumulation function here, is concave up. Hope this helps. Talk with you soon.